Uh, Hello everyone. This is your host Hassan Al Banna Himel, and welcome to our today's session on calculus for AI and ML. Just hold up. Yeah. Hello everyone. I am your host Hassan Al Banna Himel, and welcome to Calculus for AI and ML Day 1. Today is June 19, 2024, and this session we're starting another awesome journey in calculus for AI and ML. In previously, we have completed our linear algebra and we also completed our probability part, which is important for which is important mathematics parts for AI and ML. So, what we are going to learn in today's session. So, in this session, in today's session, we will be see the introduction and then we will see the frameworks which is needed for uh, lin- this calculus part, and finally and then we will see the intro to differential calculus and then intro to integral calculus, and then finally we will conclude our today's session with the method of exhaustion. So now let's start and see some introduction for the calculus. So what is calculus? Calculus is mainly a mathematical study of continuous change, like when we are going in a straight line, or if we look at the reference, like you are driving a car or any vehicle, it is going speed, right? Maybe it is mile per hour or kilometer per hour. Every time it is rising and lowering, so it is the changes, it is changing continuously. And moreover, if we want to see where we are using this, like the calculus in our machine learning and AI, we're using, we can say two examples, like gradient descent and number two, back propagation in neural networks. So how it works: gradient descent is an optimization algorithm which is used to minimize the cost function in machine learning models. So what are the applications here? In the gradient descent, we have applications like training neural networks, and also we can say the linear regressions can be applications for our gradient descent. And on the second one, the backpropagation in neural networks. Backpropagation is a method in training neural networks. We can train our neural networks with the help of backpropagation. So there are some applications, like we can say number one, that error minimizing can be a application for our backpropagation in neural network here, and second one can be deep learning models and something like that. So we also know that it has two parts. One is called differential calculus and other one is integral calculus. In the differential calculus, we simply do the differentiation, and on the integral calculus, we do the integration part. So now let's see some frameworks we use in the calculus, or we will be using in the future tasks, like doing the maths or doing the calculation using Python. In we will do the all the codes and all the coding problems in our Google Colab. So we will be using here. I have given 5 frameworks. At first, we have NumPy, SymPy, SkyPy, Pandas, and Matplotlib. So what is NumPy? Now let's jump into the what are these NumPy, SymPy. It is like it. all are the frameworks of Python. It is all the libraries of Python which helps us to compute or which helps us to solve the mathematical operations in for us in machine learning or training models. So what is NumPy? NumPy is actually an framework of Python which helps to do the mathematical operations or something like that. So we can say that it helps in efficient array computations. NumPy provides support for multidimensional arrays and matrices. It enables the efficient numerical computation, which helps us to solve any maths easily to do it more precisely. And on the second point, we got integration with other libraries. It serves, our NumPy serves as a foundation for many other libraries in Python, like SciPy, Pandas, Matplotlib. We have seen in the previous slide, right? We have seen that it is helping us to, there were 4 to 5 that NumPy, SciPy, SymPy, Pandas, and Matplotlib, and many other things. So NumPy serves as the foundation. It serves as foundation for many other libraries like that, SciPy, Pandas, and Matplotlib. And on the third point, we got vectorization for performance. So NumPy allows for vectorized operations which eliminate the need for explicit loops. Sometimes we need to do something in a loop. So in NumPy, we can do it, allows us or it helps us to eliminate the need for the explicit loops. So now let's move on to our next slide. Here we are seeing the SymPy. So in the NumPy, actually it worked with arrays and matrices, right? But in the SymPy, it helps us in symbolic mathematics. So here we can see the symbolic computation. SymPy enables symbolic mathematics, allowing its users to perform algebraic manipulations, calculus, equation solving, and many more. And secondly, it has extensive mathematical functionality. It provides a wide range of mathematical functions and tools, which includes simplification, differentiation, integration, series expansion, and many more. It helps to make it versatile for various mathematical problems. And on the finally, we it is also integrated with Python. So we said it earlier, right, that it is a framework or it is a library of Python. So we all know that it will be integrated with Python. So on the second part or on the third part here, what is SciPy? SciPy is mainly for a framework or a library which helps or provides a wide range of tools, or it is mainly used for scientific or technical computing. So we can also say that SciPy provides a wide range of tools for scientific and technical computing, including modules for optimization, integration, interpolation, eigenvalues problem. We have seen eigenvalues problem in the previous, in our linear algebra, in the matrix parts, and many more. And it is built on NumPy. So we can say that if we can learn NumPy, it will be easier for us as it is the foundation of the SciPy, SymPy, Pandas, and such all of this. And it has extensive algorithms and functions. So in the SciPy, it includes numerous algorithms and functions for advanced computation, which helps us to solve the as much problems or as much problems we can solve with the help of SciPy or using the pandas. So now sorry, it was SkyPy. My bad. So now let's jump to our pandas. So what is pandas? Pandas is another powerful library which is again authorized or integrated with Python. It is so powerful that it is designed for data manipulation and analysis. It provides data structures like series and data frame, which are ideal for handling structured data, which we are when we are training some machine learning models, we have many data sets, like right, we have a data set of many values, so it helps us in data manipulation and analysis to do all the problems more efficiently. Again, it has integration with other libraries, we got Panda, we got NumPy, we got SymPy, we got SkyPy, and many more. And finally, it has rich functionality and flexibility. Pandas helps in handling missing data, merging and joining data sets. As I said earlier, it helps us in the it helps us to it helps us in machine learning models to help or handle data in our ML models, and it also helps in reshaping data and time series analysis. And finally, we got Matplotlib as our final framework for Python, which will be used. So, Matplotlib is usually used in comprehensive plotting models. In the on the linear algebra, we have plotted some graphs. If you remember, we plotted some graphs. We can say that we have plotted a data set which helped us to learn about the linear algebra or the matrices part more efficiently. So it is the matplotlib which helps us to plot the our data set more precisely, which will help us to find the data more accurately. When you do something like we do some mathematical terms, we sometimes it bothers us, right? If I can see these problems, it will be more helpful for me. When we plot this, it will be helpful for us to do the it will be helpful for us to solve the problems more precisely. And also it is customizable and flexible, and it also same goes for integration with other libraries. It also works with pandas, numpy, skypy, sympy, and many others. So now let's start our main journey here. So here comes our intro to differential calculus. So what is a differential calculus? We can say that when we were at first slide, we say that when you travel in a vehicle, there it has speeds, right? It has sometimes it is increasing its speed and sometimes it is decreasing its speed. So when we got some slight differences, there is changes, right? If we go for 51 mile per hour, then you can increase your speed to 52 mile per hour. So there are differences. There are many decimal points in between 51 and 52. In this differential calculus, we can study the rate of changes. The primary concept is the derivative, which represents the rate at which a function's value changes concerning changes in its input. So we can work as tiny as possible value. With the help of differential calculus, we will be working with limits in the upcoming sessions. So it will be help us to clear our vision more clearly to how to solve these differential calculus problems and something like that. And secondly, finding slopes and tangents. It is used to find the slope of a curve. Like when we have something curve, we can find the slope of a curve, right? At every point there is a different slope. Each point there is a linear slope we can draw. At every point the slope will change. It helps us to determine the tangent line to a curve and solve problems involving motion and changes. Like as I said earlier here, that when we're working with motion, when we're traveling from one place to another, we got different velocity, we got different speed, which will be calculated, which can be calculated or find the more efficient or the more closely change of rates with using of the differential calculus. And finally, it helps in optimization. It, as I said, it helps in finding the local maxima and local minima of functions, and also which are critical points where the function reaches its highest or its lowest value in a given region. So we can say, right, that in the differential calculus, it helps us to study, or we can find the rate of changes which happens in this, from a vast scale to a as, as smaller as possible scale we can do with the help of differential calculus. So that was our intro to our differential calculus. Now let's move to our second, or intro to integral calculus. So what is integral calculus? Simply, if we can see that integral calculus is totally opposite of differential calculus. The primary concept here in integral calculus is the integral or integration, which represents the accumulation of quantities such as areas under curves, total distance traveled given a speed function, or the accumulated growth of an investment. We have all seen a trading curve or an investment curve, right? So we can find the integration, or what will be our integration here. We can do all these problems with the help of our integral calculus and fundamental theorem of calculus. The theorem links in differential calculus and integral calculus, stating that differentiation and integration are inverse process. We have said it earlier. If I have, this is my differentiation, and this will be my integration. So it is like it is the one and opposite part. If this is differentiation, this will be my integration. So we can say that it is the inverse process. My This one is the this person inverse, and this one is this person inverse. So we can say that differentiation and integration are inverse process, and it has two main parts. So what are those? At first, the first part states that the integral of a function's derivative over an integral interval equals the change in the function's values over that interval. And what is the second one? In the second one, the second part provides a method to evaluate definite integrals using antiderivatives. So in the future sessions, we will see what are antiderivatives. We will see what is integration, what is differentiation. We will see some chain rules, some maxima, minima. We will see limit, and many more exciting topics are waiting for in our future sessions. So we got two integrals. It has, one is our differential calculus, my bad. One is definite integrals, and the second one is indefinite integrals. So what is definite integrals? Here it calculates the accumulated quantity over a specific interval, providing a numerical value. For example, finding the area under a curve between 2 points. Right, as I said earlier, when we are traveling from sorry for that. At first, we can say that, as we said earlier, right, when we are traveling from distance one to distance two, it can be many curves, right? For at first up, then down, then up, then down. It can be many. In our perspective, speed can be increase and decrease, and many more. So, in the definite integrals, we will be given some upper values and the lower values. So, it will help us to find these areas under a curve between these 2 points. It will be helping us to find some values in the upper limit and lower limit and something like that. So, and on the what is our indefinite integrals? In the indefinite integrals, it represents a family of functions and include an arbitrary constant. If you have done some integral calculus or integration, you have always seen that we will be leaving a c or a constant at the back. So it is always an indefinite integrals. It is essentially serving as the antiderivative of a given function. So yes, we can say that those with an arbitrary constant are indefinite integrals, and those we have our 2 points that works as our upper limit and lower limit will be our definite integrals. So now we're at our concluding topic for our today's session, our calculus for ANML day one. It will be the method of exhaustion. So method of exhaustion is mainly if we go back in time, it is mainly from the ancient times when this wasn't properly introduced. This differentiation and integration was not properly introduced to us, or we don't know much about the differentiation and integration. At that time it was using the method of exhaustion, and this method of exhaustion is directly based on the integral calculus. The integral calculus is directly based on the help of the method of exhaustion. We will be doing maths on method of exhaustion, and we will do the chain rule, limits, and more in the sessions. In today's session we won't do some maths problems or something like that. From next sessions we will be doing the mathematical problems and many more. And it has iterative approximation. So what is iterative approximation, or what, how can we define this, or how we can do the method of exhaustion? It gives us a question, right? So we all got a question. So what is the method of exhaustion, what is iterative approximation, or how to do that, blah blah blah, and many more. So this method involves inscribing a sequence of increasingly finer polygons for areas, or the polyhedra for volume within a given shape. And that was our iterative approximation. And finally, it helps us in limits and convergence. What is limit and convergence? As the number of sides of the inscribed polygons, we know what is a polygons. It can be a triangular, it can be a rectangular, it can be many more. It can be hexagon, pentagon, octagon, it can be anything. We can find everything with the method of exhaustion. As the number of sides of the inscribed polygons increases indefinitely, the total area of these polygons approaches the area of the original shape. This concept is an early form of the area of a limit, which is foundational in the calculus. So we can also say that this method of exhaustion or this kind of methods are the foundation or the foundation worked as foundation in our calculus, in our differential and integral calculus, and many more. So that was for our today's session. This was our day one for calculus in AI and ML. I'm your host, Hassan Banna Himel. If you have any questions, you can ask me. We will wait for 1 to 2 minutes for any questions. Then we will close our today's session. So, for this 1 or 2 minutes, let us recap what we have learned in today's session. In today's session, we have seen the introduction. There, we have seen what is calculus or how to do that or something like that. And on the next part, we have done what are the frameworks and what were the libraries we've used in Python or this training these machine learning models or how to do this. We will be using NumPy, SymPy, SkyPy, Pandas, Matplotlib, and many more we will use in training machine learning models and working while we will be working with datasets. And then we'll have seen the introduction for the. Okay, so can we have the outlines throughout the whole sharing? I will share the whole outline within 1 or 2 hours. It is ready. I will be posting on my social platforms that you will find that the whole outline there. Thank you. And then we learned about the differential calculus, and then we have looked through the intro to integral calculus. We have seen what is integral calculus, and then we have looked at the method of exhaustion or how to find the method of exhaustion. So that was pretty much for our today's session. So hope that it was helpful for you guys, and it was also an amazing session for me to sharing my knowledge with you guys. So hope you guys hope to see you guys in another session. Till then, take care. Thank you, everyone.